Hello and welcome to the prototype demonstration video for Team Can Do, working on the generic Ethernet gateway for Mr. Anthony Torrey of Chrysler. To run the prototype, a modern web browser with HTML5 and JavaScript support must be used. Minimum supported browsers include Firefox 2.0, Safari 3.0, Chrome 4.0, and Internet Explorer 9.0. This prototype has not been tested on mobile devices and cannot be guaranteed to run on them. To access the prototype, go to the Team Can Do website, click on Public Links, Prototypes, and click on Prototype version 2. The prototype visually simulates what happens on the system in different scenarios. Operation of the gateway can be visualized using these 9 basic scenarios: data transfer, low voltage, normal voltage, shutdown port, enable port, reprogram CAN node, reprogram gateway, IP diagnostics, and denial of service. Each scenario corresponds to each button on the control box. In some scenarios, users can specify the nodes involved in the scenario by using the corresponding drop-down above the buttons. Below the visual model, there is a status box which displays the most recent status of the system at the top of the box. The first and perhaps most commonly used scenario on the gateway is data transfer. A user can specify which ports send and receive the message with the drop-downs above the scenario buttons. After the user clicks the Transfer Data button, a data packet, signified by a yellow square, starts from the source node, goes through the flash, and finishes at the destination. The status of the system is also updated to explain the data transfer in more detail. Similar to data transfer, the denial of service scenario simulates what will happen if the system detects that one CAN port is sending too many data packets. After clicking the Denial of Service button, data packets will move from one port to another as specified. However, the system will detect that too many packets are being sent. The sending node will be disabled, signified by becoming grayed out and the placement of a blinking red X at the intersection of the CAN link and the gateway. The port will then need to be manually re-enabled using the Enable Port button with the corresponding node selected in the drop-down menu. The next scenario allows users to shut down or enable specific CAN ports. This is done using the corresponding drop-down menu with the Shutdown Port button. After the port is shut down, the corresponding CAN node will turn gray and there will be a blinking red X placed at the intersection of the CAN link and gateway, signifying that the port is no longer active. If a port has been shut down, the user cannot transfer data to or from that port. When the user enables the port, the corresponding CAN node will turn back to green and the red X will disappear. For reprogramming a CAN node, the user can use the corresponding drop-down with the Reprogramming CAN node button. After the user clicks the button, a data packet starts from the Diagnostics and Reprogramming node on the AVB switch, goes through the flash, and finishes at the destination. After the data packet arrives at the destination, the CAN node will be reprogrammed and all other CAN ports will be shut down during the process. The status of the system will be updated when the reprogramming process starts and finishes. For the reprogramming the gateway scenario, a data packet starts from the Diagnostics and Reprogramming node on the AVB switch, then goes to the gateway. After the data packet arrives at the destination, all the CAN ports on the gateway will be shut down and the reprogramming process starts. The status of the system is updated as the reprogramming process starts. The system will be rebooted after the process finishes. The IP Diagnostics scenario button sends data packets starting from the Diagnostics and Reprogramming node on the AVB switch, which then go to the gateway. The data packets containing fault codes will be forwarded back to the Diagnostics and Reprogramming node. The status of the system will be updated as fault codes from the database are being forwarded to the IP Diagnostics endpoint. Lastly, the 2 voltage scenarios simply update the status of the system based on the amount of power available. The low voltage button gives a shutdown status, which occurs if the system drops below 6 volts. The normal voltage button restarts the system, which would happen if the voltage is greater than 6 volts. This concludes the prototype demonstration for the generic Ethernet to CAN gateway. Thanks for watching.